I'm Dev Poodle. Today I'll be showing you how to make a basic Godot for CRT screen effect using shaders. I have a basic scene setup here. Don't worry, you don't have to have anything like that. You should be able to follow through all the steps even on a completely new Godot project. To begin, there's some project settings we're immediately going to want to change. So you go Project Settings, then you want to go to Display in Window. So Viewport Width and Viewport Height. Let's change this to a more normal 1280 by 720. Then we scroll down under Stretch Mode. We want Viewport, and that should be good. So let's close that. Make sure to save the project. The immediate thing we need is a way to actually run a shader across the whole screen. So let's just go into a scene. Again, you can create a completely new scene and it'll work just fine. Create a canvas item, or canvas layer, sorry. Then under the canvas layer, you want to create a mesh instance 2D. Now, for the mesh of this mesh instance 2D, we'll do a quad mesh, and we'll make it the same resolution as the screen, so 1280 by 720. Now what we're going to do is set the material for this. So scroll all the way down. There's a material here. You don't want to use this material. You want to use the material under canvas item. So create new material. We're going to create a shader material. Create a new shader. So I'll create a new folder called Screen Effect. And we'll call this screen effect.gd shader. Create. Alright, we'll open that up. Okay, so we're not going to be using vertex at all. We're just going to be using this fragment shader, so we can just delete all of that. So what we want to do is type in render mode, and there's a couple things here that will help, like having it be unshaded. And I believe skip vertex transformation. So if we run the scene here, we should just get a completely white scene, and we do not. That's because we need to offset it slightly. So under mesh, you see the center offset. We want it to be half of the size of the thing. So half of 1280 is going to be 640 on this, and then half of 720 is going to be 360. All right, now when we press F5, it should actually cover the entire screen. All right. So the first thing is we want to be able to actually see what's under here. So to do that, the first thing we'll need is to create a uniform sampler 2D that we'll call screen texture. And we'll put a colon and then hint screen texture, and then put a semicolon at the end there. So now what we want to do is we want to set the color of each pixel equal to the texture, screen texture, sampled at UV. Now, as you can see, it's actually flipped. So that's because we don't want to use UV, we want to use screen UV. And now it will match up perfectly with where it's lined up. So if you run the scene, as you can see, it's practically as if the object was invisible. All right. Now, most of this CRT screen effect is going to come from the screen warping. That's where we warp the UVs. We can make a quick example of what the current UVs look like if we do color equals vec for screen UV 0, 1, and then a semicolon. This is what the UVs currently look like. As you can see, it starts at black in the upper left corner and then goes to yellow as it goes to the bottom right corner. So this is linear, so it goes from 0 black to 1 red and 0 black to 1 green as it goes down the various corners. And then yellow, of course, is full green and full red at the same time. So what we're going to want to do is warp this so that it's not linear. The first step is getting our UV centered. So we're going to make a vec2 centered UV. At the moment, it ranges from 0 to 1 on both sides. So what we want to do is have the center actually be 0. In order to do that, we want to do screen UV. We multiply by 2 and then subtract 1. And now if we rendered what the centered UV looks like, as you can see, it's black towards the center. And this whole black region, that's actually because it's in the negative numbers and it doesn't really know how to render that, so it just renders it as black. All right, the next thing is we're going to create a constant that we're going to call curvature. It's going to be a float. For now, we're going to set it to 7. You'll see what this does later. You might even want to make it a uniform eventually, but for now, we'll just have it be a constant at 7. So we're going to create a new vec2 called UV offset. This is going to be the centered UV. And we actually want to swap y and x in this case. And then we're going to divide it by curvature. All right, and let's see how that looks. Well, as you can see, we're dividing it by 7, which means it's very, very close to 0 for most of the image. The next thing we do is we apply this UV offset to the centered UV. So let's call it warped UV equals the centered UV plus the centered UV times the UV offset. And then we actually want to square it, so it's times the UV offset again. And now if we render this, it's kind of hard to tell. Let's go back to the code we were using before that we commented out. Instead of screen UV, let's use warped UV. Now this isn't actually going to be perfectly correct. You can see some warping happening, but that's because I forgot to uncenter it. So in order to uncenter it, we do basically the opposite of what we did to center it. So we add 1, and then divide by 2. Alright, now you might slightly be able to see it, although it might be kind of hard to tell if we run it in a scene. Now it should be more obvious that the edges are being warped. So as you can see, the bottom line here is curved. Now we can really exaggerate this effect by lowering this curvature. So it's actually kind of inverse. So for example, if we set it to 2 and run the project, as you can see now it is incredibly warped. Now, something you're probably noticing is we're having a lot of really weird effects on the edge of the screen. We ideally don't want that. So in order to reduce this, what we're going to do is we're going to make the area past the screen texture black. That will more accurately represent what a CRT TV would look like. All right, in order to make that cutoff, we want to see when the warped UV, like the absolute value of warped UV, is greater than 1 in either direction. So we're going to call it cutoff. Sorry, it's going to be a vec3, I believe. So we're going to start out with a step function. That means we'll do warped uv.x, and we want to take the absolute value, so abs. And we're going to step it with 1. And then we're going to multiply it by basically the same thing, except using warped uv.y. Now, I'm unsure if this actual work. Okay, well, actually, the first thing we need to do is wrap it around a vec3. Then let's actually create a new thing called screen color, which is going to be essentially just this. .rgb. And then we'll replace this with vec4 screen texture. So essentially it uses all the values of screen texture, then a 1 in alpha, because we want it to be fully transparent. Oh, sorry, screen color, not screen texture. Oh, and we want to remove this texture, I forgot. All right. So now should be exactly the same as what we had before. But this time, we want to multiply it by cutoff. So we do times cutoff. All right, seems like this is working. So if we run this, now it's actually working. The areas that were being distorted before are now cut off, so that it's only showing the exact same thing as what we were showing without the screen distortion. As you can see, 7 is a really extreme, or sorry, 2 is a really extreme example, so let's go back to 7. This kind of has the same effect, but it's a little more subtle and it's probably closer to what you'd actually want in a video game. So the next thing we need to do is add scanlines, because you really don't have CRTs without scanlines. So we're going to achieve scanlines in a very similar way to how we achieved cutoff. So we'll do vec3 scanlines. It's going to be a vec3. For this one though, we want, so I'm going to have horizontal scanlines. And one way to get that sort of repeated thing is by using a sine. So we're going to use the sine of warped UV dot y. Then we're going to multiply it by the resolution. So we don't actually have resolution. We know our y resolution was 720, so we'll multiply it by 720. You might want to make this a constant or a uniform, so that whenever you resize the window, it changes with it. But for now, we'll just have it at a regular 720. And then we'll also multiply it by 2, so that's doing every other pixel. Let's put a semicolon, so that stops giving me errors, and multiply this by scanlines. Now, this is kind of messy. This isn't really what we want. So let's multiply by 0.25. This will make the effect a little more subtle, but also make the screen much darker. So then we'll add an extra 0.5. And as you can see, that works pretty well. We actually could add 0.75. That might be a little bit closer to what you want. So now, as you can see, if we run this, our resolution actually is pretty high. Let's lower that. Right, because if we want it to match the actual individual pixels, then we want that to be significantly lower. In my case, that might be like 360, although it might even be lower than that. Let's try 180. Alright, now this is actually what I want, because the scan lines are now matching about in height with the actual size of the pixels. So this might be kind of trial and error. There actually is a way I could have calculated this based on like the camera zoom and stuff, but I just didn't want to do that. So as you can see, this is pretty close to how we want it. Of course, you can always make the effect more subtle by decreasing this and then increasing this like offset value. So now it's really a lot more subtle. This actually might be much closer to what you want in your actual game. So as you can see, the screen warping and the scanlines are already giving it a pretty nice effect. But in order to really make it feel like a CRT, we need to add some vignette. Like that's going to be the thing that really pulls it all together. So vignette is again going to be accomplished in a very similar way to how we did both of these. And we'll want to multiply the screen color by vignette. Oh, actually, now that I think about it, that's not how we're going to do it. What we're going to do is we're going to take screen color and subtract vignette off at the end. We're doing vignette slightly differently just because of how we're getting the vignette. So we're going to take the absolute value of our centered UV. This, as you already saw, is a symmetrical thing that is 0 at the center and gets closer and closer to 1 as it reaches outwards. And we want to actually raise this to the power of 4. Now we actually have to make this a vec2 with 4. Then we'll divide this by 3. And then finally, this is a vec2, but we want a vec3, so let's take the length of this. Now, as you can see, we already sort of have vignette effect. We want to have a multiplier, so we'll add a new constant called vignette multiplier. It's float. Let's have it be 2 for now. And then here, when we're subtracting vignette, we multiply by vignette multiplier. All right, now if you run the scene, now we have a vignette. As you can see, it does really tie a lot of like the edges together. We don't have that like harsh cutoff towards the corners now. And it's much closer to the CRT screen effect that we want. All right, now the last thing I'm going to do is I'm going to add a little bit of blur, because the way most CRT effects work is you have a little bit of bleed between the different pixels, and adding a tiny bit of blur is a good way to simulate that. So we're going to go to screen texture, and we're going to filter linear bitmap. Essentially what this will do is it will allow us to filter the texture linearly, which will allow us to get a little bit of blur. So now we're going to change this texture function to texture LOD. And this is where we're going to require a new argument. That's a float. For now, let's set it to like 1. And as you can see, we're already getting like actually too much blur already. So 1 is a little bit too much. Let's lower it to maybe the 0.1. Alright, this is a slightly better amount of blur, although I think I actually want to increase it a little bit. So, of course, this is another thing that you might want to make a uniform or a float. So as you can see, this is a pretty decent CRT screen effect. You may want to increase the brightness overall. For example, in these Scanlines, instead of plus 0.8, let's do plus 0.9. And yeah, I think this is a little bit better for readability. So yeah, thanks for watching. This is how you make a CRT effect in Godot 4. I hope this helped. See you next time. Goodbye.